Hello. My name is Ashley Williams, and you might know me from being rather prolific on Twitter as AG Dubs. And I hail to you from the good old US of A. Briefly, what I do want to say is my slides are online. If you like to interact with slides during someone's presentation, feel free to pull these up. I give a lot of quotes. There's a lot of sources in this, and so you might want to check that out later for reading. But yeah, as I was saying, I am from the United States, but these are not really my red, white, and blue. I'm a little bit more into this, or maybe blue and pink. And yeah, so as it was said, I work at the Mozilla, and I work at the Mozilla Foundation. Does everybody know that there's two parts to Mozilla? Maybe some people? No. All right, so I work for the nonprofit part, as you probably already sensed. I'm not super into money. But yeah, so what we do is we build open source tools that focus on developing universal open web literacy. And that's kind of a mouthful, so what does that really mean? And what that means to us is that we believe everybody should be an informed consumer, but also creator of the web. And so for me, in particular, what this means is that I like to think about thinking. I was not a computer science major. I was actually a philosophy and neuroscience major. But with that being said, I like to think about thinking, especially the type of thinking that happens when people write code. So the theme of this conference is work-life balance. And when I was asked to speak, I was kind of like, I don't really know if I'm on topic. So we'll find out. So to start off, let's talk about cows in space. Yes, yeah. Is that better? I'm like breathing into it, I can tell. How do I fix this? I'm also loud, so I can just talk. Please stay black. Hello? Is that better? You guys not hearing me do the human breathing thing? Awesome. That's better for me too, because it was bothering me. All right, so again, work-life balance, cows in space. Right? This is what we're going to talk about today. And maybe in addition to cows in space, we'll talk about art. This is some great art that I found on the internet. It's licensed, I promise. But I'm also going to talk to you about JavaScript. Who writes JavaScript in this room? So fun, right? The breathing. Sorry, I'm going to try not to breathe while I talk. Yeah, so we're going to talk about JavaScript. And in particular, we're going to talk about ES6, or ECMAScript 6. I know that some people think that you should say ES 2015. Spike is driving me nuts. But I'm going to call it ES6 from now on, and if people on the internet get mad at me, I don't really care. So, what does that really have to do with work-life balance, right? Maybe right now you're thinking, this girl's going to go off the radar. She's talking to us about cows. Lots of cows. Right, what does that have to do? So what I'm going to do is kind of give you a primer. We're going to talk about better living and working through looking at beginner experiences. And then additionally, we're going to do better living and working through interdisciplinary understanding. And so as a general umbrella, if you're wondering where I'm going, that's where I'm going. We're going to do that now?
You're not happy without it. You could have muted it, but you can also mutilate your hair. Yeah, that's the other option. There you go.
I'm only wearing a dress for my mom. Anyways, okay, so to get through this, what we're really going to start talking about is this awesome idea called abstraction. And really, this is going to be the takeaway. So we're going to return to this image, but when we think of this image, I want you to think about abstraction. So this wouldn't be a good computer science talk if I didn't quote Dijkstra, right? So let's do that. Let's get that done. All right, so Dijkstra says, the effective exploitation of his powers of abstraction, his or hers, must be regarded as one of the most vital activities of a competent programmer. And so what Dijkstra is saying here is that when we're programming our most essential, our job is to abstract.
And so Benjamin C. Pierce, in his famous book, TAPL, Types in Programming Languages, he defines something called the abstraction principle, where he says, each significant piece of functionality in a program should be implemented in just one place in the source code. Where similar functions are carried out by distinct pieces of code, it is generally beneficial to combine them into one by abstracting out the varying parts. And so hopefully when you read this, you're like, yeah, I've done this. This is my favorite part of programming, when I get to refactor things. This is the joy of programming for me. But in addition to understanding abstraction in a rather practical way, I want us to also think about it kind of theoretically, maybe academically. And so, for theory and academia, what I do is I go to Wikipedia. That's the best part, right? Yeah. So here in Wikipedia, they say, abstraction tries to factor out details from a common pattern so that programmers can work close to the level of human thought. We're going to flag that. That seems a little strange. And then, so close to the level of human thought, leaving out the details which matter in practice, but are immaterial to the problem being solved. Danger, Will Robinson. All right, so again, we're going to flag this too. Immaterial to the problem being solved. We know as programmers that one of the big things in our job is defining the problem. If we don't do a good job defining the problem, inevitably our solution is going to be terrible. All right, so let's think as we go through this about what problems we're trying to solve. So as Christian introduced me, I was a teacher. I was a middle school science teacher in Harlem, New York for 3 years. But after that, I also ran a boot camp program in New York City. And while there are some things about boot camp programs that are a little shady, this one was awesome. It was called the New York City Web Development Fellowship. And basically what you had to do to apply was you had to be unemployed or make very, very little money. And then what we would do is we'd take you from no programming experience at all through 6 months of a lot of work, and then actually guarantee you and get you a job as a junior developer in New York City. And so this is my class right here. It's pretty cool. And so I've learned a lot from these beginners. And it's amazing because, at least in America, we don't really value our teachers. But the insight that teachers get from working with beginners every day is something that we need to make a more prevalent perspective. And so one of the things I learned was that iteration is really hard for beginners. It's really hard. By the way, this is the only slide with code. Deal with it. All right. So a couple of weeks before I was supposed to start my program, I was hanging out with the dean of the school. He was giving a talk at a Ruby user group. And his main thesis was that Ruby is amazing because it's written so expressively that even your mom can understand it. Sidebar, don't say that. Moms are cool and smart. Don't be rude. Anyways, so he was like, this is very clear. It's written in English, hilariously enough, by someone who only speaks Japanese. Anyways, he said, this Ruby is great. This JavaScript, look at all of this punctuation. I have no idea what's going on there. No way. And so you might get the impression that I'm about to disagree with him, but before I do, what I am going to say is he has an important point. So these are two amazing computer scientists, Abelson and Sussman. They wrote a book we're going to talk about later. But this is a really key quote. And here they say, programs must be written for people to read, and only incidentally for machines to execute. So when we spend a lot of time, writing and writing, we're pissed about bugs, all right, we really should be concerned about writing code for the people who are going to maintain that code, for the people who are going to read it. Code is an interface. And we really do not do a good job of dealing with that. And part of the reason is there's this issue about making it for people to read. What does that mean? Because sometimes reading things is hard for people. This is my front door in Brooklyn. This is a note to the UPS person to open the door that is not locked and leave the package inside. And here's a note saying that they missed me. So I thought, potentially that was good for them to read, but apparently it didn't work out. This is a tricky problem. All right, so back to this iteration. So we're a couple of weeks into the New York City Web Development Fellowship, and I'm sitting at my computer working on some curriculum, and I hear my assistant teacher, Blake, he's teaching iteration to the class, and it's not going well. People are really frustrated. People have really no idea what's going on. And I'm sitting there, and as Christian suggested, I had a bold idea. And so I decided to walk into the room, and I interrupted the class. And I was like, all right, what I'd really like you to do is completely forget all of the Ruby you just learned. It's pissed you off, whatever, just forget that it happened. And what I'm gonna do is I'm gonna teach you iteration using a language that you don't know. And so that's kind of a radical thought, right? It's like, well, we don't know JavaScript, why are you gonna teach us iteration? And here's why. Because in JavaScript, we don't have an abstraction that obfuscates the underlying implementation. Iteration has three major concepts: state, condition, and increment. If we look at this lovely for loop here, we have our state, we have our condition, and we have our increment. And from there, we're able to see through the syntax the underlying programming concepts, which in the original each statement was completely abstracted away. And so it turned out, despite the fact that I didn't have a lot of faith from my students at the time, that they figured out iteration and they worked on through Ruby and eventually got each. So one of my favorite physicists, I don't know if you recognize this man. I like to say he's my secret 80s boyfriend, but this is Thomas Kuhn, and he says something very interesting about this idea. All right, he says, the real problem in speech is not precise language. The problem is clear language. It is really quite impossible to say anything with absolute precision, unless the thing is so abstracted from the real world as to not represent any real thing. And so here we see some conflicting issues. We had Ruby, it was supposed to be expressive, easy to read, all right? But with that clarity, we lose precision. And at the same time, we were trying to make it real language. And in that, we ended up doing a lot of abstraction. All right, and so we have these two issues that we desperately want to fix. We want to be able to write code efficiently, expressively, but we also know that there's people there who need to maintain it, who need to be able to read it. And so this man, who is the painter of that lovely Bulls photo that I keep putting up, all right, he kind of gives us a little bit of an answer, or maybe problematizes things further. He says, there is no abstract art. You must always start with something. Afterward, you can remove all traces of reality. So we're kind of stuck. Where do we begin? When we're thinking about building a programming language that's supposed to attain all of these goals, where do we start? Do we start with abstraction, expressiveness? How do we do this? And so this is a favorite photo from going to conferences. If you've been to conferences, you may have seen this before. But I'd like to say that this is particularly poignant here, because this is what a lot of programming languages do to us with their abstractions. So if you can't read it, it says, how to draw an owl. 1, draw some circles. 2, draw the rest of the fucking owl. That is the only curse word in this talk. All right, so yeah, we're stuck here. Is this a good way to learn how to draw? No, this is terrible. All right, and we are doing this with the programming languages we design. All right, so this is terrible. This is way too abstract. This is terrible because how on earth do we get here? This is way too precise. All right, so we're kind of in a pickle. I know you guys are a fan of street art. This is some Brooklyn street art that I really like, and this is kind of how I feel when I think about the conflicting influences we have when we're designing programming languages, particularly with a beginner audience in mind. All right, so many of you may not have realized, but my talk is actually an homage to this lovely gentleman, Carl Sagan. Do we have any Carl Sagan fans? Yeah. I didn't know if it had made it to Europe. I don't know. I love this guy. All right, and so for us, as I said, I kind of studied neuroscience, and so something I do want to talk about is our journey beginning with negotiating these different needs in our design, beginning here. All right, so back to the cows in space, right? You guys like that? It's good? Cool, all right. So again, our cows in space. But here we go. So humans are amazing pattern recognizers. It's actually amazing that our books are actually what we keep using as a medium. We're terrible at reading them. We have terrible short-term memory. We are designed to see visual patterns, all right? And so what we were able to do is we were able to look at this sky here and see this. You see it, right? I don't know. Someone saw it and he convinced a lot of people. All right, so yeah, we're great pattern recognizers, and when we name our patterns, all right, these are our abstractions. And something that's really important to recognize is that the abstractions we make are important and determine our culture and our community. There is nothing worse than a bad abstraction. So you can know that when we have these constellations, out of this, we created a whole community of astrology. And while this one actually, it's saying that I'm going to suggest something outrageous, so this is actually pretty accurate. We do see a lot of people sinking tons of money and time into this community that's based on terrible abstractions. Look at this. We have daily dog scope, cat scope. Does anyone know what AstroSlam is? I have no idea what that is. All right, and so we need to understand that these cow paths that we're paving, yes, I'm sticking with that cow metaphor, it's not going away. All right, with these cow paths that we pave, these abstractions are our community. And so we need to be very careful about the ones that we decide to make. All right, here we go. It's JavaScript time. All right, we got our cow. We're going off into space. So JavaScript has been a delightful beginner programming language because it has lacked abstractions. Us who are not beginners, of course, may find it somewhat more frustrating, but this is going to be a point that I hope you bring up in questions. All right, this is all going to change. Okay, so September 28th, 1980 is when JavaScript was invented. Yeah, definitely not. Good job, guys. You're on that. All right, no. It's the day that this show Cosmos came out. And the reason Cosmos was such an important show was that it decided that scientific concepts, despite their complexity, were so important to the community that they needed to have the attention to be expressed in layman's terms. All right, and so out of this, we had this great quote. If you wish to make an apple pie from scratch, you must first invent the universe. And it sounds a little ridiculous, but what he's trying to say here is that the complexity of how the universe works matters, and it matters to you in your day-to-day. And so when I heard this, I was like, yes, if you wish to learn ES6 from scratch, you must first invent the universe. And that wasn't Carl Sagan, that was me, but I'd like to think he supports me. All right, so let's talk about ES6. So this is from the spec. I'm going to read some spec here. It's very fun. ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. Now, relaxing is like a pretty good message. Like, I'm relaxing here in Germany. I guess not before this talk, but before that. But it's not always the right message. For example, a dating app. Don't send that as your first message. That's real. All right? So what we need to realize is, like, does JavaScript exist because we didn't have any relaxing programming languages? Probably not, right? We have to ask ourselves, what is material to the problem being solved? What is JavaScript trying to solve? All right, and it's kind of a heavy question, but what will JavaScript's legacy be? Like when we look back and we see this weird artifact, a bunch of people were writing this language. What are they gonna think about it? And like, that's a huge question. And I'm certainly not capable of giving a full answer, but I'm pretty sure it's gonna have something to do with this. So Laurie Voss is the CTO at NPM. Any NPM users here? Yeah, okay, a couple. I'm a server person, so I love NPM. And so what he says is this. Fundamentally, it's hard to think of a compelling reason a brand new web dev would learn 2 languages when they can just learn JavaScript. Now he follows up. If I could pick any language in the world to use on both server and client, it might not be JavaScript. But we don't get to pick. And that brings me to ECMAScript classes. Is anybody using classes right now? All right, we got a couple people in the audience. All right, cool. So you can see here, I'm already flagging something here as dangerous. So I'm gonna start out by saying that sugar makes me sick. Like, actually sick, I have type 1 diabetes, that's real. But syntactic sugar also makes me nervous. And the reason is because oftentimes syntactic sugar obfuscates the underlying concepts, it obfuscates the implementation, and those things are actually very, very important. All right, so here's the crux of my issue. This is from the spec. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based. Okay, so we have class syntax, but we don't actually have classes. So you might not need class syntax. No one saw that. All right, so this is my favorite part of the talk. And if you have been zoning out, just wake up for 1 second so you can get through this, and then you can go totally zone back out. This is a lovely man named George E.P. Box, and he says this is the most wise thing ever. Remember that all models are wrong. The practical question is, how wrong do they have to be to not be useful? All right, let's see how wrong we are. In a class-based, object-oriented language in general, state is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited. Now that's maybe a little bit hard to follow in just text, especially if you've just heard of this for the first time. So there's this great guy named Regenwald on Twitter who's known for being awesome and saying things like this. He wrote an amazing blog post, and I'm not going to read this to you, but he's like, prototypes are not classes. All right, when we teach classes, we always talk about classes are a boilerplate. All right, they're like a blueprint. We have a blueprint, and then we make an object from it, and that object is just much like a house. The problem with JavaScript classes is they're model homes. All right, you could leave them empty, but also someone could move in. And I don't know if you have any Arrested Development fans in here. I love this show. All right, so JavaScript classes, they're just objects. They're not classes, really. And so you might think that in this I'm saying TC39, which is the group that writes the ECMAScript spec. This is ginger ale, by the way. I was very sick. All right, you might think that I'm saying, go home, TC39, you're drunk. But no, this is not a hate talk. All right, in fact, hilariously enough, someone asked me before this to make a class warfare joke. And so my partner followed up by saying he was sure I'd have a few good prototypes. I didn't, which is why I screenshotted Twitter. And so my argument is really easy to break down. You could easily come at me by being like, all right, you're saying it's not a real class? Well, what even is a class? And what I'll tell you is at the after party, I'd love to talk to you about a language called Simula, which is when classes and object orientation was first introduced. So if you are interested, I can talk your ear off about that, but I'm already running low on time. So what I am going to say about ES6, and especially classes, is that JavaScript might be trying to do too many things and not actually be any of them. This is a real place. It's outside Madison Square Garden. I don't really know what happens in there. And that's kind of how you can feel about classes. All right? So one of the things is we want to be looking at designing this programming language for its users. And one of its users are beginner programmers. Leslie Lamport, in one of his excellent talks called Thinking for Programmers, which I strongly recommend you read, he quotes this great cartoon, and he says, writing is nature's way of letting you know how sloppy your thinking is. And so what I like to say is teaching is nature's way of letting you know how sloppy your understanding is. Do we have any teachers in the audience, by the way? Not one. You guys should all become teachers after this. All right, so those people, Abelson and Sussman, they wrote this really seminal book on computer science education. What they said in it was that we need to teach programming concepts, not language features. Before this, when we taught programming, we always taught syntax. And already, if we decide to change this paradigm, we see we have a conflict in JavaScript. Our syntax actually does not match up with programming concepts. It makes me terrified to think of teaching classes in JavaScript. All right? JavaScript will be the introduction to programming concepts for an entire generation of programmers, whether or not we like it. We don't get to pick. All right? And so one of the things that's material to the problem we're solving in JavaScript is how friendly it is to beginners and how well it's able to teach them programming concepts. All right? And so are we totally lost? Not necessarily. So in a follow-up to that structuring computer programming book, this man, Peter Van Roy, who's a computer scientist, wrote this book called the CTM, where he talks about teaching programming as a unified discipline. And what we can understand from this is the idea that programming languages are tools. And so when we have a programming language, we understand that it solves a particular problem. And the solution it gives, paired with that problem, is understood as a paradigm. And so some languages are very good at one paradigm, and some languages are good at a lot. And it looks to me that as JavaScript develops, it's going to have to be multi-paradigm. All right? And so how do we teach this? And the way that we do it is spoken about by Peter Van Roy in this quote. He says, a good way to organize a programming course is to start with a simple language and then to extend this language gradually. So he has something called the kernel teaching method. All right, and from here, he starts them with nothing. You build the idea of scope. It's fascinating. All right, and so you might think that I'm saying, all right, everybody should learn to build a kernel method. Like, that's probably not a good idea. But what we do know is when we build our abstractions, all right, we are doing that work of inventing the universe, all right? All right, so we don't want to write the kernel language. This is a terrible idea. No one would ever want to be a developer. It's a pretty painful process. But what we can take from this is the idea that when we have abstractions, we shouldn't teach the abstraction outright. We should first introduce the problem it solves and only have the beginner implement and then use the abstraction when they feel the pain of its absence. And we already know this as developers, right? We know pre-optimization is a bad idea. Ron Jeffries of Extreme Programming says this: always implement things when you actually need them, never when you just foresee that you need them. So prototypal inheritance is a big part of the JavaScript universe. And with classes, we're not going to get away with not teaching it. We're going to have to. And in that sense, it makes me wonder, why don't we build sugar around the actual stuff that we have in our language and not sugar that actually hides the concepts in it? All right? The prototypal inheritance is how the apple pie gets made. This is a vegan-friendly metaphor. Shout out to vegans. All right? And so I've just gone through quite a bit. All right? And I kind of give this TLDR because I'm a teacher and I love summaries, and I'm not going to read it to you. Instead, in the last couple of minutes that I have, we do understand we have JavaScript, we have abstractions. Abstractions aren't good for beginners. When we teach, we have to start at the beginning. But there's a better calling here. And I want to ask you, and yeah, this is going to get a little cheesy maybe, but what do we even mean when we talk about programming? This guy is Martin Heidegger, and he is one of my favorite philosophers. And in this book, What is Called Thinking, he states this: the most thought-provoking thing in our thought-provoking time is that we are still not thinking. And you might see where I'm going here. But I want to ask, are we programming yet? Is what we do in its essential time, when you think about all the time you spend programming, are you really doing that beautiful act, that joyful act of abstraction? Or are you putting in another semicolon that you forgot? Right? I know you are. Unless you're not using semicolons at all, which is a thing, whatever. All right? People in the academy are doing some great stuff with this. They're really asking these questions. And they're building languages like Racket and Pirate. Have any of you guys heard of these? Maybe this one? Yeah, so this is a great language. It's coming out of MIT, and it's really having people build programs by moving blocks around. All right? And so this is happening in the academy, but I want to ask, why is it not happening in industry? All right? This is a man named Thomas Kuhn, a philosopher and scientist, and he says this: scientists work from models acquired through education and through subsequent exposure to literature, often without quite knowing or needing to know what characteristics have given these models the status of community paradigms. Why do we want classes in JavaScript? Do we need them? Did we ask? We have an awesome opportunity to think more radically about how we extend JavaScript. In fact, we have this with all the abstractions that we build. I want to leave you with this from Sagan. We start and end with Sagan. It is far better to grasp the universe as it really is than to persist in delusion, however satisfying and reassuring. And with that, I'd like to ask us to reconsider our ontology, to consider it a lot, to think about it often, and to stay beginners. Thank you very much.
Okay, why do we need object orientation in JavaScript? Because our universities teach object orientation as programming, and people want to hire people as quickly as possible and turn them into JavaScript developers.
So I love to say that Plato ruined it all.
Yeah.
Yeah, I'm not a fan of object orientation, and I do think that it's fundamentally easier to reason about functional programming. Unfortunately, there's an inertia in the academy right now that's really keeping that aside. I'll also say that generally speaking, there's also a cultural problem with that community.
Yeah, maybe. I did a lot of Coder Dojo work where you get like 7 to 12-year-old kids and they bring their parents along and start coding, and we use Scratch. And I found that with Scratch, it gets kids very excited, but it also ties them into an IDE kind of thinking. You know, they're using a system rather than learning the language underneath. So what would be a good way to break that?
Yeah, that's a really fascinating question. When we think about computer education in general, there's like kind of two things that are at opposing angles. Obviously, these opposing dichotomies are my favorite structures. But the issue is that you need to get people excited and keep them motivated. But at the same time, you need to build them with more extensible skills. And I completely agree that the IDE ideology is toxic. So it's tricky, and this is something that's exciting about the web and some of the things, and this is not a plug for Mozilla at all. Thanks for the tweet. Is the idea of being able to use the browser as an IDE. And so the browser itself is not really an IDE, but at the same time, it affords you a lot of these things. And so tools, there's a tool called X-ray goggles, for example, that allows you basically to jump into the source code and modify it. So like going to the New York Times and like changing all the pictures to cat photos and changing a headline to be like, happy birthday to me, is something that allows you to interact with real tools and see real code in a way that you would as a normal developer, but doesn't necessarily tie you to the idea of an IDE, because the browser is somewhere that you would be working if you were in an actual job.
The problem that I see mostly with ES6, and I'm on the forefront of that because we have to, we're actually implementing it a lot, is that right now you cannot use it in browsers, so a lot of people go through transpiling to convert it into something that actually runs in browsers. So instead of having that beautiful like right-click, view source, find what the page was about, we're getting more and more into a space of abstractions and build scripts, and especially in CSS as well. Most people show Sass examples rather than CSS examples because of the syntactic sugar, and every keystroke is a prisoner. So less code is better than more code. How can we break that kind of concept in our community? Because I think it's just a very dangerous thinking.
So there's two things I'll say about that. I'll address the first one, which is about the transpiling, and I'll say JavaScript is in puberty right now. And so it's going to be a little awkward. I do not want to stop people from trying things out, because we need the forerunners to go in there, find all the bugs, report them, and develop it. I do see in the future, though, that this is a temporary thing, the transpiling. However, with the Sass and the pre-compiling of those assets, I think that's a very interesting question. And fundamentally, it comes down to the idea that we can't rely on tooling instead of educating ourselves. And so Sass can also write beautiful CSS, but in the wrong hands, you can have deeply nested selectors that are super not performant. And it's really about learning how to use the tools correctly, I think, in that matter.
Isn't partly a thing of the web growing up as well? I mean, I hate myself for saying that because I've been on the web for a long, long time, and I love that immediacy of building, seeing the difference, building, seeing the difference. But every other aspect of software works a lot with abstracted libraries. Like nobody writes a game for PlayStation from scratch anymore. They have SDKs that they just use. Everybody uses hardwired methods inside the video cards for OpenGL programming. These kind of things. Do we just fool ourselves that the web is always going to be different, or do we have to align to the whole market that's out there sooner or later?
Well, I'm not sure it's the market. What we really need to understand is that the abstractions go super, super deep. We have tons of abstractions in the web already. I mean, how many of us have written a browser? I mean, I'm looking at y'all. It's actually a really fun exercise. It's worth doing. But we have abstractions on every level, and it's really, when we think about crafting our abstractions, is we need to do them correctly, and the API that we expose needs to be thoughtful. I mean, we're working on top of assembly. I mean, that's like an abstraction that's always happening, and it's about exposing a thoughtful interface. And if we do that, I think that we'll be okay. because it's infinitely deep. We could go down the rabbit hole forever.
One controversial thing I said in one of my talks is that jQuery bred a whole generation of developers that don't understand the basics anymore. Would you agree with that?
So, for certain values of the word basic, I think that there's something that a lot of people, because they had jQuery as a tool to interact with the web, actually do fundamentally understand. Do I think jQuery bred the most bright programmers in the world? No. But what I do think it did is made people active creators on the web. And in that way, they also are able to understand how to consume the web. There's things about how a browser interface works that they're able to understand because they were able to use that tool. Do I think that it's often used as a crutch? Yes. But do I regret that it occurred? Absolutely not. I think it was one of the most formative moments in like web history. Like jQuery will go down as introducing a whole generation of people that like this is something that they can do.
Are we out of time? Yes. So thank you very much.
Yeah, thank you.